Hello learner, welcome once again to Manifested Online Classes. My name is James Kenyani. I'm happy again to continue with the topic Surds. The topic Surds. So today we are actually going to look at what a surd is. A surd. What a surd is. So the lesson is Surds. So the main objective of the lesson is to enable the learner to identify what a surd is. So the main objective is to enable the learner to identify what a surd is. So we start by considering a few numbers before we come to that. Consider. So if you consider those ones, they have a perfect square. They have as square root of 4 is 2, square root of 0.16, 0.4, and 0.3 respectively. So such numbers tend to go to a class of rational numbers. They are rational. But surds, but the following do not have perfect squares. They do not have perfect squares. So roots that do not have perfect squares are called surds. Roots that do not have perfect squares are called surds. Expressions such are called surds. They are called surds. Expressions with roots that do not have perfect squares. Sometimes the squares are called roots. Because here you'll be taking off square root, but you have fourth root, are called surds. And you'll discover in the first lesson, all surds would then be irrational numbers. All surds are irrational numbers. All surds are therefore irrational numbers because they cannot be expressed in the form P over Q. Then we have order of surds. Order of surds. Order of surds. They also have an order. We have order of surds. Learner, you'll reach a word like that. So square root of 7, square root of 11, square root of 21 are surds. These are surds of order 2. Surds of order 2. When we come to cube root of 20, cube root of 11, and cube root of 28, cube root of 28, these are surds of order 2. These are surds of order 2. Order 3, not 2. These are surds of order 3. We are learning these orders because it will be very of paramount importance when we are simplifying, when we are multiplying, when we are making some operations on surds. We also have these. Fourth root of 60, fourth root of 17, and fourth root of 23. These are surds of order 4. Are surds of order 4. So you should be able to differentiate the surds, especially the root is one that gives it the name. The root you can put here 2. Square root is as if a 2 is here. So it gives its order 2. Cube root, order 3. Fourth root, order 4. So learner, those are the orders of those ones. So just as a recap of what we've done, let's go back. We've considered numbers. We found out that some numbers that are having a perfect square tend to be rational numbers. But the following, like here, they'll not have a perfect root. They do not have perfect squares. They do not have perfect square roots. Perfect square. They do not have perfect square roots. Expressions that do not have perfect squares or roots, perfect square roots. So the best is to write perfect square roots, are called surds. All surds are therefore irrational numbers because they cannot be expressed in the form of P over Q. Then we've looked at the order of surds. The order of surds. So if it is a square root, it's order 2. Cube root, order 3. And notice the number here does not have a perfect third root or square root or fourth root. That's why it qualifies to be a surd. It qualifies to be a surd. So in the assignment for surds, so in the first question, which of the following is a surd? Which one of the following is a surd? So if it is a surd, you write surd. If it is not a surd. In the second one, state the order of the following surds. You just learned about the order of surds. So you'll do those 2 assignments before we jubilantly meet in the next lesson to continue learning about surds to make us more happy and not to make us sad as the topic goes. So thank you very much, and let's meet in the next lesson. Bye-bye.